All right, let's take a look at another example of some kind of complex conditional probability, something where the book would want you to use Bayes' formula. And I'm going to show you again how you don't need to rely on these big complicated formulas. If you just use some basic understanding of how probability works and some logic, which is what this is all about. Let's learn some logical thinking. So here's the information we're given. There's a nice little kind of description that a manufacturer buys items from 6 different suppliers. So here are your 6 suppliers. And then the fraction of the total number of items obtained from each supplier is in this column, and then along with the probability of their items being defective. So you could think of, maybe this is a car manufacturer. This is Chevrolet or something building cars, and they get their transmissions from 6 different companies. And so these are the 6 different companies that provide them with transmissions for their cars. And then out of those 6 suppliers, they buy more from one and less from another, maybe because they're closer, so shipping costs less and things like that. And then of course everybody manufactures defects, so there's always going to be a certain number of defects from each supplier. So according to this, for instance, supplier 1 gives them 5% of all of their transmissions, and out of all those transmissions that they give to them, 4% of that 5%, right, is defective, and so on and so forth, right? Now they want you to find the probability that a defective item came from supplier 5. So basically what they're asking is, you're now the line foreman, and you're out there on the line looking at them building cars, and a car comes off the assembly line and the transmission is defective. So you now have a defective transmission. And you want to know, all right, well, based on how many transmissions I get from each of my 6 suppliers, and based on the probability that they supply me with a defective transmission, what's the probability that this defective transmission came from supplier number 5? Now it's kind of a silly question, because in the real world, of course, you would, each transmission would be linked with who you got it from. You know exactly which supplier gave you that, so you could go back to them and say, you're going to pay me for another one, and blah 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 and all that kind of stuff. But so that we can actually do the math, we're going to pretend like we don't know, and we just want to know what's the probability that this transmission, or this item, came from supplier number 5. So can you see how it's a conditional probability? I'm given this one transmission, given that it's defective, right? Because we're told it's defective. That's the given. So given that this transmission is defective, what's the probability that it came from supplier 5? So they're basically saying, what's the probability that it came from supplier 5 given that it was defective? So we know from previous videos and previous ideas that in order to do conditional probability, it's still good over total, right? Because it's still just probability. It's just the total now is the given stuff, right? Instead of looking at all transmissions, we're only looking at the defective transmissions, because the one we have is defective. So we need to figure out how many total defectives we have. And then out of those total defectives, we need to figure out how many, came from the thing we're looking for, supplier number 5. Okay, now it's really quite simple. If 5% of my fraction of my entire supply came from supplier 1, and 4% of those things are defective, if I multiply those 2 decimals together, that will give me kind of the total amount of defective things from supplier 1. And I will do that with all of these pairs and get all of the, let's say, numbers of defective things. And that's how I can get my new total. But instead of dealing with decimals times decimals, as I've done with previous examples, it's a lot easier to play with some numbers. Let's put a real world context to this instead, and let's think about this in real terms. So let's pick a number for the total number of things that are supplied, right? So what's the total number in this case, the example that I used, what's the total number of transmissions that are being supplied to Chevrolet? Well, anytime you're dealing with decimals and percentages, it's always nice to have whole numbers. So let's pick 100 because then 5% of 100 is just 5. Or really any kind of multiple of 100. You could go 1,000 or 10,000, right? You could do 200 or 400 if you want, but it's usually easier to just do one with a bunch of zeros. And I just pick 100 because it just makes the math easier. So I'm just going to say the total transmissions is 100. So that means instead of fraction of total supplied, I can do number supplied, right? How many were supplied from each one? So, 5, 12, 16, 23, 35, and 9. You get the idea, right? Because 5% of 100. And so now 4% of their supply is defective. So I'm really just going to take 4% of 5, and I'm going to get a fraction. And 2% of 12, and I'm going to get a fraction, and so on and so on and so forth. Well, if you don't like dealing with fractions, then instead of using 100, use 10,000. Put 2 more zeros on it, right? If you put 2 zeros on here, you're going to put 2 zeros on here because 5% of that, right? So you're going to have 500, 1,200, 1,600, da, 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 da. And now they all end in hundreds, right? 2 zeros. If I take a 2 decimal, right, number of it, I know I'm guaranteed to always get whole numbers, and then I'll have whole numbers at the end. So if you really hate dealing with decimals, it's really easy to avoid them. But I'm going to go ahead and leave these as decimals, and then I'm going to fill in these first couple with you, and then I'm going to put them all in at once. So if you want to do the math yourself, go ahead and pause the video now and compute all of these, and then I'll give you the answers here in a second. Okay, did you get the same numbers as me? Right, 5 times 0.04 is 0.2, next one's 0.24, 1.12, 0.23, 1.05, and last but not least 0.45. If you add all those up, because we know that we need to do, our new total are all the total defectives. So remember, it's like 0.2 transmissions and 0.24 transmissions, and it doesn't make sense, but we still add it up and we get 3.29 total transmissions. Those are how many total defective transmissions we get out of a batch of 100. So that becomes our new total. And on the bottom, we have 3.29, okay? On the top, right, in order to do this conditional probability, we got to figure out of those 329, right, what are the good? i.e., what are the ones that satisfy this question? And this question is that it came from manufacturer number 5. And if we look at our new numbers, 1.05 is how many defective transmissions we got from supplier number 5, right? So these are the defectives, right? 1.05 is how many we got from number 5, or supplier number 5. They really should have made these A through, whatever, G or something. 1.05. So there's my good, right? The defective ones that came from supplier 5. My total number of defectives, 3.29. We do that math, and we get 0.319, which is the same exact thing they got here. I mean, you can see the numbers are the same. It's just top and bottom and multiplied by 100 because we used n equals 100. And you can see the math in the Bayes formula. All Bayes formula is a generalized formula that tells us how to do this same concept. The top number is always the good, and in this case, it's how many things from our given are from the thing that we're looking for, right? So because we're looking at supplier number 5 and being defective, then we take the fraction of supplier number 5 and multiply it by its probability of being defective, and that's where the 0.35 times 0.03 comes from, and there's that. And then the bottom, we're just adding up all of the defectives, getting us that new total. And so that's each multiplication of its fraction of supplies times probabilities. But if you just use numbers and think about it, it makes more sense than all these crazy decimals everywhere. So again, Bayes formula is fine. It's awesome. It works, right? It's theoretically sound, but why use it? Why make your head explode and get headaches trying to figure this out when instead just use some logic, use some numbers, and think your way through it.